We're trying to bring back, oh, thank you, Riley. Yeah, that's good. We're trying to bring back as many past E2 Tech people to our 20th anniversary celebration. I've heard from people who came to our first event. We used to meet at Maine Audubon regularly and so forth. And I'd love to hear those stories. The last thing I want is to be there at the event and have somebody say, oh, you forgot to honor this or that person. That would be a shame. And a quick aside is that quite a few luminaries have contributed to the early inception and growth of E2 Tech, including Angus King, who apparently said, this state needs an association of engineers and technologists to work on matters of the day, and John Baldacci, who spoke at our first event. So there you go. So good morning. My name is Marty Groman. I have the honor and pleasure of serving as Executive Director of E2 Tech. You know us. We call it clean tech. Some people say, environmental, the pocket protector people trying to make the world a better place. And 310 plus member companies. Won't you join if you're not a member? It helps advance the sector over in Maine. Here in Maine, we've been doing it for 20 years, and it really helps move things along. The joke is I'm networker in chief. If I can connect you with mass timber startup in Millinocket, or a healthy building project, or one of the panelists that you see today, or somebody in battery recycling, that's my job, and I'm happy to do it. Everything is these events are free for students. Your support makes that possible. You sending a tweet and tagging E2 Tech or putting up a LinkedIn post is always really appreciated. One of the most rewarding parts of my job is helping people find new employment that works for them, and particularly for new Mainers. I have a particular focus on doing that work. We've been working with IntWork, which is a diversity recruiter, and we've been able to make several placements, and we're hoping to make many more. And we are very pleased and blessed to work with the Maine Technology Institute. Other states don't have, Brian Whitney always corrects me when I say this, other states don't have something like the Maine Technology Institute. It's technically true, Brian, because of course it's not the Maine Technology Institute in Massachusetts, is it? But it really is a remarkable organization with tons of support for your company. Doesn't have to be a startup. Maybe it's a new product line, a new product that will do, active online monitoring of hydrogeology or something, and you want to add that on, go to MTI. They have a new fund of $40 million. Applications are open right now. Let us know if we can help. We're very engaged in doing that. These companies make what we do possible all year long. They support us throughout our work. Bernstein Scher Law Firm, Power Market, Community Solar, SMRT Architects and Engineers, and Con Edison Transmission. Of course, Bernstein Scher, great partner and supporter, and members of the program committee. And I always like to linger on this slide a little bit. Same deal here. These are companies that make an ongoing support. We're a micro organization, a nonprofit. Our annual budget is, less than $200,000. I think that's one of the reasons we've, sort of survived over the years. We keep it kind of lean, but these companies make what we do possible. So please patronize them. If you need contacts at these companies or interested in doing projects with them, I can connect you with the right person. TRC and VHB connect and support every one of our panels all year long. So thank you to them, and please work with them. And Maine Biz, would you like a free print subscription to Maine Biz? I get one myself. It comes out quick. There's all kinds of good information in there. Just send us a note, info@e2tech.org, and we will get you a free print subscription to Maine Biz. This event today brought to you by St. Germain. St. Germain, check out their website, a wide array of environmental services, everything from managing oil spills to every type of remediation and planning, zoning, you name it, an excellent company that we can highly recommend. I can highly recommend you come to our next event after this one, which is live in person, brought to you by the sponsors you see on the right at Maine Beer Company. Register, don't miss. light on talking, heavy on networking. Great chance to get together. Wonderful venue in Freeport. And we have some stuff in the works too. We just set this up yesterday. We're going to get a state of the state on aquaculture, very timely, lots of things going on. My first event as C2 Tech Executive Director almost exactly 3 years ago was an aquaculture event. And we really haven't gotten back to that topic area. We just want to hear from Sebastian Bell, what's going on. So we'll have that in our A2 Tech Connects format. Our program committee is concerned about grid planning. It's a frequent topic for us. Electricity rates rising. We're planning a 3-part series. You know how our program committee works. You don't have to be a member of the board. Any E2 Tech member can contribute. If you'd like to be part of that, we want to hear from you. And we want to hear your ideas for our next panel. So yes, a Zoom webinar. Yes, we're recording. Please use the Q&A panel. And you can use that at any time, of course, right through the entire, you can ask a question right now. In fact, I think some people are. Amanda is an environmental engineer with a long and varied background in exactly the field we're going to discuss today. And we're really pleased to have her as moderator. Amanda, I'll leave it to you to take the helm from here. I'm in the background to support you and sip away at my coffee while you lead this great forum, and start out by introducing our panel for this morning.
Great, thank you, Marty. I just want to take a minute to thank everybody for being here this morning. I know in my immediate circle of family and friends, I've always been considered a little odd to have a passion for solid waste issues. Why would I want to spend so much time on such a gross topic? And I can certainly say that looking at the large number of participants we have here today who are willingly spending 2 hours on a Zoom call at 8 o'clock in the morning, right after breakfast, to talk about waste, I'm in a good company. And these are the sessions that we need to do to make sure that we can move through all these issues that we're facing in Maine and elsewhere. There certainly have been a number of challenges over recent decades that we've faced in waste, whether that be hazardous waste, solid waste, or wastewater processing. But it really is rare to have an issue come before us that really touches on all facets of solid waste management the way that we are today. PFAS really has become an issue that all industry is facing, all industries, municipalities, and it's something that this gives us an opportunity to try to get ahead of as much as we can. As most of you know, the DEP did run a program for quite a few years that promoted the use of septage and sludges in spreading on fields, really to regain the nutrients from that material and to help divert it away from our landfills. It's always been a big goal to help to conserve the capacity we have available in the landfill and to promote that hierarchy. And so, up until recently, that was the option that just seemed like it was the best one for us. Recent changes, recent developments in laboratory technologies that have allowed for very low-level detections of PFAS have started to provide us an opportunity to take a look at what we're seeing around these sites. And with that, there has certainly been a growing concern about the impacts that we are potentially going to see in our groundwater, sediment, et cetera. With that, the state did recently pass a law that prohibits future spreading of sludge-containing materials and ultimately the prohibition of septage spreading as well. So, the plan for this session today is really to dive into this topic to provide an opportunity to discuss with, the experts and others on where we are today, where we're headed, what options and opportunities are available to us for the sludge processing, sludge disposal. It's here. There's nothing we can do about it. We all produce it every day. And certainly we need to come up with a plan that works best for everybody. And so we're hoping that this panel discussion really gives some information about the options we have and provides a glimpse into what opportunities might exist into the future. So, as Marty said, we have some experts here facing it every single day. We're also going to provide, some input from a municipal association in how, both industry and municipalities, how are they looking forward to help with solving this? How are they planning to deal with short-term changes and long-term changes to their processes? And at the end, we are going to have an opportunity to address all the questions that come in from you guys today. So please, as Marty said, make sure you're posting in that Q&A so that we can get to as many as possible. We'll take a look at the number of questions that have come in by the end of the session to see if we need to maybe also provide some written comment if we can't get to everything within the session today. But with that, I'd like to turn it over to our first speaker. Janine is the executive director of the Northeast Biosolids and Residuals Association, and she'll be providing a lot of information on kind of where we're headed with this problem.
And unmuted, if you can hear me. Thank you, Amanda. Just quickly, Northeast Biosolids, we're in our 25th anniversary year, Marty, and our mission is to cooperatively promote the beneficial reuse of water and wastewater solids, hydrosolids and biosolids, as they're called. Let's see, why is that not moving? All right, just a little background, which for your information, on the 1987 amendments to the Clean Water Act were really what established biosolids, turned sewage sludge into biosolids, but it established the pre-treatment program, which was key to improving the quality of these materials. And it also set up the biosolids management programs that we know today. In those amendments, it was pretty clear that Congress wanted EPA to find uses for these materials and not just disposal options. And they also directed them to do the science to make sure that whatever pollutants are in there don't interfere with those end uses. And they intended to leave it up to local governments to determine how to manage it. So this created what I like to refer to as the three-legged stool of biosolids management. It's a little wobbly right now. And I just want to point out that at this time, none of those legs of the stool really destroy PFAS or deal with the PFAS problem. Just quickly, I need to talk about the benefits because these programs are not the easiest and cheapest to implement, but we feel they are the most sustainable. And as Amanda mentioned, there's a lot of benefits and nutrients and things that are in these materials that it's great to put back into the earth. Concerns, as they've always been, about odors, over applying nutrients, especially phosphorus and nitrogen, and trace contaminants like PFAS. And in the past, it's been dioxins and PCBs and other materials. Again, the benefits, we feel NEBRA has this new tool that we've been implementing, the Biosolids Emission Assessment Model, to give managers some information on the climate impacts of these different management options. And, when we look at these, probably the best option from a climate standpoint is anaerobic digestion, followed by land application of the materials. But you can see, and I just want to point out, the red bars are methane. And that is a very powerful, like 22 times more powerful than just CO2. So we like to try and keep the big picture in mind as we're doing these assessments. But in the past, Maine has done a lot of land application and beneficial reuse, but currently, and in 2018, you can already see the shift to landfilling has started to occur. And yeah, just a little fun fact there, for the state of Maine, average solids generation per person per year is about 36 pounds. So that's about the size of my dog, just to put it in perspective for you. We do know a lot about concentrations of PFAS in biosolids, and I just want to highlight some really great work being done by Michigan's environmental agency. They did a study of all of their treatment facilities, and you can see on average, it's about 13 parts per billion. of PFAS compounds in these materials. Oh, this is just for one, PFAS. But then you can see there's clearly a trend, and there you can see where if the facility has industrial discharges in their system, you can see the impacts. So just what we're trying to do to maintain or increase, we could use a fourth leg of the stool, we could use a fifth leg of the stool. We really need to have more options available to local municipalities to manage these materials. So, and we're working on a roadmap right now for that, which involves source identification and some source control strategies, and then just encouraging folks to research, study, and pilot some of these emerging technologies that we're seeing. Speaking of emerging technologies, here's a list of some of the ones that NEBRA's been trying to follow, and certainly pyrolysis and gasification. There are some biosolids facilities in commercial operation using that technology, which came to us from the solid waste sector, actually. And so we're just going to need to have some support to try some of these new things and experiment. And we're hoping that, you know, that will happen pretty quickly. And I think this is my last slide, and I just wanted to step back a little bit and kind of look at it from a regional perspective, because this is a regional issue, in my opinion. What happens in Maine is going to impact other states, and vice versa. What happens in Massachusetts, which generates the most solids out of any state, is clearly going to impact other states as well. So some of the market pressures, some of the things that are going on is that we just have fewer incinerators, certainly none in Maine or Vermont. We have landfills closing pretty regularly. I think we're down to about one major landfill in each state now. And since the LD 1911 ban, Maine's going to have an issue finding some homes for their materials. Massachusetts has been exporting about 70% of its solids, so they're going to have to find a better way. And just keeping an eye on different things that might be a barrier to new technologies. So for example, there's a proposed law in Massachusetts to restrict anything that emits PFAS, and it's pretty generic, and could be a barrier to experimenting and trying some of these new technologies. But like I said, I think this is a regional problem, and we're talking about regional solutions, and maybe I can get into that a little bit more later, but that should set the stage, I think, for you, Amanda.
Excellent. Thank you, Janine. We did have one question that came in, and would you take just a moment to go back to your PFAS slide? I think we had a question on what your x-axis was on that slide.
Yeah, so micrograms per kilogram, that's parts per billion.
Okay, and this is just number of facilities here across the bottom?
Correct.
Okay, thank you.
Yeah, it's just the individual facilities.
Perfect. Thank you so much.
You're welcome.
And I guess one other question, do you know where Massachusetts is exporting to?
Jeff could probably answer that more, but other New England states, and also transporting to southern state incinerators.
Okay,
and
so
Canada.
we will okay.
And Canada.
Awesome. Thank you. I think we'll hold the other question to the panel discussion, and we can move right along. So Rhonda Forrester works with CV and Mahar. She's a civil and environmental engineer. She's going to give us a discussion today on the impacts of using or placing these sludges in our landfills today. So take it away, Rhonda.
We will be sharing the slides, by the way.
Okay, good morning. My name is Rhonda Forster. I'm a project manager with CV and Mahar Engineers, an environmental consulting firm in Cumberland, Maine. And today I'm going to be giving the engineering perspective on sludge placement in landfills. I'm going to talk about the different waste streams that are accepted at landfills typically, then talk about sludge placement and how that impacts stability and operability. I'll then talk about the recent impact of recent legislation on sludge disposal options, and then I'll close with some options on how we can think about managing sludge and septage in the future. And Janine went over, kind of what sludge is and where it comes from. And as you can see on this slide, there are two pictures that are just showing just examples of sludge. But the point I want to make with this is that sludge itself is not a consistent product across the board. Depending on whether it's generated from a municipal facility or an industrial process, it's going to have slightly different properties. So that's something that people that manage sludge have to also keep in mind when they're working with it. Now, the waste that's accepted at the landfill typically falls into one of two categories. You have your high strength waste and your low strength waste. There are a couple of examples of high strength waste shown in the images here. Oversized bulky waste, as you can see, things like sofas, furniture, and just large items that take up space. Likewise, your construction demolition debris, also a bulky item. If you think about a house tear down, you're going to have pieces of wood and shingles and even pipes and other materials that come out. Things that can be recycled are pulled out, like your metals, but other items that can't be recycled or easily disposed of, or composite materials, have to be disposed of in a landfill. And last, as a bulky item or as a high strength waste, you can see municipal solid waste. So that's the waste you and I generate in our homes. So these are the bulky items that come in that have to be landfilled. But as I mentioned, landfills take a lot of different waste depending on what their permits allow. And that could also include some low strength waste, such as sludge, different types of ashes, soils that have been contaminated but meet the limits of the landfill, and then also what we call processing fines. So the small particles that are generated as larger construction demolition debris material are being sorted. And all of this has to get mixed in at the landfill. Now, sludge in particular is a material that requires some extra attention and thought before it's placed in the landfill. Because it's a low strength waste, it has to be mixed with a higher strength waste to provide so that it can be stabilized, and that the additional waste placed above that material is also going to be supported. So we often do what we call bulking of sludge, or mixing it with one of our high strength waste materials. Now, as we saw, there are three different types of high strength waste: your oversized bulky waste, your construction demolition debris, and your household waste. But they all have different strength properties. So from a mixing standpoint, your oversized bulky waste, that's ideal for mixing with sludge, just because it doesn't take as much material to stabilize the sludge. You have about a 4-to-1 ratio of your oversized waste, to one part of sludge. Likewise, if you're looking at all low strength waste or non-bulky waste, you need upwards of 6 parts of that material to 1 part of sludge to get any sort of stabilization. Now, a landfill in any given day is taking a variety of material, and at any given time, they're not going to have all oversized waste or all CDD. They're going to have a mix of materials. So in general, a landfill operator has to look at what is available and then make decisions on what the volume is needed. So often they're working in that ratio 4-to-1 to 5-to-1 for sludge bulking. Now, other things we need to be aware of, in addition to how much material we're mixing with our sludge, concerns when the sludge is accepted. At a landfill, typically, you don't want to have your sludge coming in for the same hours that all of your waste is coming in. Usually, you're going to give yourself a few hours to have just waste coming in, because again, it's going to vary. You're going to be getting oversized waste, construction debris, soils. So you want to know you have a few hours to accumulate a stockpile of that stabilizing waste that you can use to mix with sludge. Then typically a landfill will turn on their sludge deliveries. They'll take sludge for a few hours, but then likewise at the end of the day, they're going to want to stop their deliveries and give themselves a few hours to then have more bulky waste come in that they can mix with the sludge for bulking. So in addition to managing the mixing of the sludge and making sure that they're mixing the waste, they also need to make sure they're maintaining a good area for the equipment to travel on. As you can imagine, if you're mixing sludge with other materials, it's going to be somewhat moist. It's going to be kind of a soft surface. And as the landfill's constructed, as you can see in the image, you need to make sure that you're able to support the weight of the waste. A landfill waste and typically has a density of about 60 pounds per cubic foot. So picture a 50-pound bag of sand and then some. That's the weight you're supporting. So you need to make sure that as you're mixing your sludge, you are creating a stable surface so that you can support the additional weight of the waste that's going to be placed above. You also have to make sure that you're placing the waste in the proper location, especially for dealing with sludge. Again, because sludge needs to be stabilized, you don't want to place that within your outer slopes. And most landfills limit sludge placement to within, you have to be at least 25 to 100 feet away from your outer slopes before you can place your sludge. And given the nature of the landfill geometry, the taller the landfill gets, the less available area you have for sludge placement. So these are all things that a landfill operator has to keep in mind as they're placing sludge and mixing their sludge with material coming in. So for this reason, most landfills try to limit their sludge acceptance to about 10 to 15% on average. This ensures they can maintain that stable waste mass, that they can mix their sludge with the bulking material so they have a stable surface. It helps control odors and the generation of landfill gas. And it's also important for drainage control. This figure here is showing, leachate, which is the liquid that flows through your waste. And typically that liquid flows through your waste, it enters your leachate collection system in there and it can be treated. But again, landfills take a variety of waste. So depending on the material that's coming in, you sometimes have what's called a lens form. And that's basically a material that comes in, it's somewhat wet, it dries out, but maybe it wasn't mixed or maybe it's just the nature of the material, but it creates an impenetrable layer. So now you have water accumulating. Well, if that's something that happens, you can imagine that's going to make it hard to have a stable surface above that. So again, that's why it's so important to really mix that sludge in and really mix your waste in when it comes in, because you don't want to have stability issues in the future. And as I've been mentioning, the sludge, we have a preference for the materials that we mix with it. We want it to be mixed with a material that can be bulked. And on average, this ends up representing only about 20 to 30% of available material that can be mixed with sludge. And the reason this occurs is, of the material that's coming in, our bulking material, as I showed in the last figure, we need to have high strength waste on the outer slopes of the landfill. So not all of the bulking material can be mixed with sludge. Some of that material has to be placed on the outer slopes. Likewise, sometimes your bulking material contains gypsum, and gypsum, when it's in the presence of organic material and moisture, can generate hydrogen sulfide, and that can lead to odor generation and other complaints and problems. So you really want to avoid mixing sludge with anything that contains gypsum. So, and then there's also the fact that some of the materials that come into the landfill have alternative uses. Anything that's a fine material, you're going to want to use for alternative daily cover. So even though that could be mixed with sludge, that has a better use elsewhere. So in the end, landfills are trying to maintain about a 10 to 15% mixing ratio of their sludge to overall waste. But even with the waste that's available for mixing, really only 20 to 30% of that waste can be mixed with sludge. And it's something that it's important to pay attention to, because if care isn't given to this, incidents can occur. There was a fatality from a stability incident at a landfill in Pennsylvania not that long ago, just in 2017. And the picture you see here was taken by a worker just minutes after this happened. The Pennsylvania DEP required the landfill to hire a firm to perform a study, and that was done by Geosyntec. And what they found were there were several factors at play that led to this failure. One, the landfill was experiencing increased sludge acceptance. They also had some drainage issues due to the type of waste being placed. They were dealing with a lot of drilling tailings, which is a material that can form lenses as the moisture leaves. And that did happen, which created some areas of instability. Likewise, because they were taking waste, they were maintaining setbacks of 100 feet from their slopes. So that gave them a really small working area. And what that did was that created a localized area where you had a sludge ratio of over 40%. So because of that and all these factors combined, they did have an issue. One of the requirements from the Pennsylvania DEP following the study was they limited their sludge acceptance to 10% per month. And that was when remediation of the landfill was occurring. And then once the remediation was finished, it was increased, given their waste mix, to 15% per month. And as Janine and others have mentioned, we're here talking about this today because it's something that we're looking ahead and realizing we're going to need to figure out how to manage. There have been some recent legislation that have been passed, and they have direct impacts on sludge placement in the landfill. LD 1639 prohibits the disposal of any waste that's generated out of the state of Maine in a Maine landfill. And part of what that does is some of that material that was used for bulking of sludge is no longer accessible. Likewise, LD 1911, which eliminated the land spreading of sludge, means that that material that was once land applied now needs to find a new disposal option. There are estimates that this is about 20 to 25% or 25,000 tons of sludge. And just looking at the table and thinking about the ratios I mentioned earlier of 4 to 5 to 1, waste to sludge, that means if there's 20,000 tons of sludge requiring disposal, that's 100,000 tons of waste that's needed to bulk with this material. So that's something that any landfill that handles that needs to be aware of. It's also something that impacts us because, as Janine mentioned, regional capacity, we would need to determine what landfills had this capacity. We need to think about where landfills were in their life. If we had a landfill that was further on in capacity, not only does it have less because it's closer to the end, but also if it's closer to the top, then they're going to have just less area available for sludge acceptance. So these are things that we just have to keep in mind. Also, landfills aren't things that can be designed, and kind of brought online overnight. These are facilities that require a lot of thought, a lot of design, a lot of review, designed by the engineers, reviewed by the DEP, and these take time. So bringing capacity online isn't something that can happen quickly. So we really do need to think about where capacity is needed and how that's going to look in the future. So going forward, when it comes to sludge, we know that landfills could be an option depending on available space and just kind of working out some of the logistics of them, making sure that they can comply with odor standards. Landfills have to have odor management plans in place and they have to reply to odor complaints. So it's expected that increased sludge acceptance could lead to just being more aware of the odor issues and working more on that. And that's something landfills will have to be prepared to do. Another option is exportation. I've heard of facilities in Canada and New York that could accept sludge, so that might be an option for others. And as Janine mentioned, people are looking at new technologies, so there could be beneficial uses of waste materials that we are able to identify in the future. And I will kind of take questions, I think, at the end.
Thank you, Rhonda. We did have one quick question that I thought we might be able to address right now. Somebody was asking about your bulking ratios and whether that's based on weight or volume.
Volume.
Thank you. Great. So our next speaker is Scott Furman. He is the Director of Wastewater Services in Portland Water District. He's going to provide a little bit of information for us on how they're, what they're looking to do into the future for wastewater.
Good morning, Marty. I think you're going to share my slides.
Yeah, I sure am. Jump right in and I'll put them on the screen.
All right. So this morning, I hope to share the perspective of a utility. Keep in mind that utilities are by nature rather conservative, and that's because of the services we're providing, the fact that people are relying on us to do our job day in, day out. So uncertainty in the marketplace, such as this, certainly makes utility people like myself quite fidgety, to say the least. Next slide, please, Marty. So the Portland Water District provides drinking water services to 210,000 people in the greater Portland area. I believe it's 11 communities. We also provide wastewater interception and treatment to 6 communities. We partner with those communities. They typically will operate their collection system. We operate the large pipes and systems that accept that flow and then send it to a treatment facility. We have 4 treatment plants. Pictured here is the East End facility in Portland, our Westbrook facility that serves Gorham, Westbrook, and a small portion of Wyndham. We have a facility on Peaks Island, and we have a facility in Cape Elizabeth. The material from those 2 plants, the biosolids, if you will, is thickened and then transported by truck to one of these 2 facilities for processing. Next slide, please. We generate an annual average of 20,000 wet tons per year at about 21% solids from those 2 facilities. To put that in context, that's about 2.5 trucks a day, every day. We tend to operate over weekends, holidays. We try to operate during snowstorms. We don't shut down, and neither do the people that are contributing to our facilities. Janine mentioned 36 pounds per day of waste coming from every one of our residents, and that's what we're asked to manage. Stepping back a little bit, our biosolids meet and have consistently met DEP screening concentrations for metals. So the bar for biosolids management was exceptional quality sludge based on having very low metals concentrations. And because of the nature of those that discharge to us, our communities, but also our aggressive industrial pretreatment program, we've had a sludge that is very low in metals. And therefore was really ideal for potential beneficial reuse. Residuals are generated continuously, and we have to manage them daily. And there is not storage capacity on site. During the beginning of the pandemic, there were obviously a lot of interruptions. That included construction in Massachusetts and other locations. That decreased the amount of bulky waste in C&D that was available potentially for mixing with biosolids. I was having weekly conversations with our biosolids management provider, and the question was whether or not they were going to have enough material to mix with our biosolids. So I've seen constraints in the past, and I've seen the potential. In fact, they asked if we couldn't service you for 2 weeks, what would you do? We've got a plan internally where we'd essentially turn half of our treatment plants into holding tanks and try to ride it out. So really not a lot of options currently to deal with interruptions. Next slide, please. And oh yeah, we take septage as well. We take a lot of it from our surrounding communities. You see an increasing volume here. I think some of that has to do with the nature of, a lot of people are at home right now because of the pandemic. And so there may be more attention to their individual septic tanks and managing those. So now that you know who we are, the rest of this, I just want to give you some perspective on some of the challenges that we're under. Policy, regulatory, and physical capacity, and dramatic change is really creating a number of challenges for us. Next slide, please. So like all biosolids or sludge generators in the state, we are asked to test annually for three PFAS, PFOA, PFAS, and PFBS. The red line on this chart shows the DEP screening limit that was established. And you can see that for PFOA, we're generally low. That's not a surprise. For PFOS, we've exceeded the screening standard. I will point out in 2020, biosolids from the East End facility was below that screening level. There have been some questions about septage, and we pulled residential septage samples when we were grabbing these samples and sent them off to the lab. And for instance, at East End, we're looking at a PFOS of about 12 or 13. Septage came back over 70 parts per billion. Next slide, please. So biosolids have certainly been in the spotlight. A lot of the current challenges began in March 2019. On a Friday afternoon at approximately 3:32, DEP sent out an email saying that the beneficial use or distribution of composting would end immediately pending facilities testing their biosolids and comparing them to the screening standards. That had an immediate impact on the management of residuals, as one might expect. Facilities tested, we began to move on. As Janine pointed out, that really shifted the dynamics of where a lot of material was going and how it could be managed. Governor Mills, in response to some of these issues, created the PFAS task force. They met, and in January 2020, they issued a final PFAS task report. There were a number of recommendations. I think Jeff's going to talk about some of those. The one I'd like to highlight is the task force recommended Maine DEP investigate the availability of treatment and disposal technologies that minimize the potential for environmental PFAS contamination. Preference to be given to technologies with demonstrated capacity to destroy PFAS. And additionally, the state should promote the development of infrastructure on the scale necessary to meet the needs of the state to manage PFAS contaminated waste safely and in a cost-effective manner. That hasn't happened. In fact, what we've seen with 1911 is we've removed yet another option. And logistically, the Portland Water District is down to really one option, and it's the Juniper Ridge landfill. We continue to look for other options, but as a large generator, that's a challenge. We're not just sitting here. We've actively engaged with the Water Research Foundation. We're a sponsor in a study for a pyrolysis facility to try to understand the fate of PFAS through some of these newer technologies. We've also begun a biosolids master plan, and we're looking at long-term options. I think right now we're focused on volume reduction, but we're also looking at PFAS destruction and sustainability. In other words, how can we make a product that is potentially attractive, but at the end of the day, easier to manage. Next slide, please. The problem is utility, we can look at some things and we can come up with ideas, but without being in step with policymakers, regulators, and legislators, and the public in general, some of our ideas may or may not ultimately be supported. Janine mentioned a law in Massachusetts, or a bill in Massachusetts that's attempting to limit any biosolids processing. Well, it's got to go somewhere. So in 2021, biosolids focus continued with the implementation of a $10 per ton fee to fund some of the remediation work and testing work. That was done somewhat hastily. DEP was not exactly sure how to implement that. And ultimately, I think in response to some of the concerns over cost impacts of ongoing legislation, that was rescinded as part of LD 1911. Just to put it in context, that would have cost Portland Water District about $250,000 a year. So LD 1911 was signed by Governor Mills. I've got a headline here from during the process. The bill has banned spreading and blend application of biosolids. It's also created a requirement for testing at wastewater treatment facilities. Unfortunately, it's focusing on our effluent only. And when DEP comes in this summer and asks us to do this testing, I'm going to stress the need to test the influent as well. My concern with just testing our effluent is it continues to perpetuate this belief that treatment plants are somehow responsible for PFAS. Stepping back a little bit, here is the world's most busiest slide. It goes back about 10 years. It shows how our material from our two plants have been utilized. The light blue down at the bottom really tells the story I want this slide to tell you. And that shows material that was either composted or digested. And we were doing a pretty good job of I believe, beneficially reusing a significant amount of our material. Anything that's blue or orange wasn't going into a landfill. And you can see that has significantly changed with all of our material going to landfill. This has certainly created budget impacts, and CDM Smith worked with NACWA, NEBRA, Water Environment Federation, came up with a study and demonstrated across the board by 2020 the impact of the 2019 disruption in biosolids management created immediate cost impacts as people shifted from beneficial reuse, particularly to landfilling. There's a link to that study. You can find it. It might be a bit outdated at this point, but it's still fairly accurate. In context of Portland Water District, our costs have gone up about just under $1 million a year in the last 2 years. And we're simply landfilling our material, but with a number of more restrictions. So that's about a 53% increase in our costs. And we expect that to continue at that rate. I saw a question in the Q&A about where PFAS is coming from. Treatment plants are receivers. We don't use PFAS. We don't add PFAS. Treatment plants are not polluters. Treatment plants are taking, I like to refer to it as we take society's sins and we cleanse them of those sins prior to discharging that material safely to the waters in the surrounding environment that we so enjoy. Conventional treatment plants are not designed to treat or remove PFAS. So again, our wastewater is a reflection of society. And if something is in our wastewater, it's there because it was added. Maine's been fairly aggressive in some consumer protection laws. And unfortunately, it's not going to happen until 2030 in terms of removing unnecessary PFAS use. By next January 2023, however, manufacturers are expected to begin identifying that they are using PFAS in their consumer materials. But a lot of the materials that we're looking at that repel grease, repel water, resist stains, there's just a lot of materials that contain PFAS. And next slide, please. Food packaging. Report came out a month ago. One food wrapper contained a whopping 100,000 times the amount of PFAS that is currently scrutinized in biosolids. And it's fairly common. I suggest that you pull that report up. Industrial discharges, typically municipal treatment plants are asked to work with our dischargers to have them limit the materials they're discharging. Those limits have to be technically based. So I think it's ironic that LD 1911 essentially removed the standard for biosolids, and that may actually create some challenges as we try to create limits for industries. I also don't think it makes a lot of sense to ask treatment plants to be the enforcers of PFAS use and PFAS removal from society. That's one of the things I like about the source minimization approach. Wisconsin is taking more of a numeric approach, a narrative approach rather than a numeric approach. And basically that's working with industries to identify potential sources of PFAS and ask them not to use those. Michigan's been fairly aggressive. So there are examples out there. We're plugged into that. And I really look forward to working with DEP and our industries to try to identify what we can do in the interim to discourage use of these materials. So in conclusion, wastewater treatment plants are receivers of PFAS. Source elimination is demonstrated to reduce PFAS. PFAS or PFOS, PFOA were voluntarily removed from domestic production, and we've seen levels decreasing. PFAS is widespread. It's everywhere. I saw a report recently that said 100% of all breast milk samples contained PFAS. Sustainable residuals management is necessary. Janine said 36 pounds a year of waste is generated. It has to go somewhere. I think we've got to shift and recognize that policy's got to support a transition from today or to tomorrow. This problem wasn't created overnight. This has been going on for nearly 50 years. I ran a half marathon last year. I didn't decide the day before to do that. I got in shape and I ran for 2 years before attempting that. And I think that's an example of, you just can't transition overnight, especially when we're dealing with something this large. Costs are being borne right now by today's ratepayers. And I really think we've got to look at, responsible parties, sustainable funding mechanisms, so that we're not asking today's wastewater ratepayers to fund a lot of this work. And then treatment plants, again, we provide an essential societal role. We are stakeholders in the search for the solution. And I think it's important that as we engage moving forward, that the concerns that we have are real. And I just ask that we be respected in the court of public opinion as we try to engage on these solutions. We're part of the solution. We are not part of the problem. So that's all I had. Thank you.
Thank you, Scott. We did have a question come in during Rhonda's presentation, and I was hoping maybe you could touch on it here. And that really had to do with sludge dewatering and drying. I know you kind of handle that step before it goes to the landfill. So can you talk a little bit about the efforts that you guys have to go through to get it, even transportable? And then certainly maybe during the panel discussion, we can talk a little bit more about the after part.
Sure. The way wastewater treatment works is it's essentially concentration. We take a waste that our bodies concentrate, and then we dilute it, allow it to flow to a treatment plant, and then we spend a lot of time through 4 or 5 different processes trying to remove water. We are currently looking at dryer technology that would further increase the percent solids. The challenge is in a marketplace like we're facing right now, making a capital decision on future investment is really quite challenging. So I think everyone's kind of in a holding pattern, waiting to see where the dust settles on the current situation before we take too many steps forward.
Thank you. I think that's helpful. And then we can certainly talk about how, these wet materials are how we're going to look to manage these into the future. Thank you.
So thank you very much.
I think the rest of these questions will hold for the panel. There is some discussion in here around product stewardship and things, and I think we'll discuss that more as a full panel. So our next speaker for today is Jeff McBurney. He is an engineer and environmental manager for Casella, and he's going to talk a little bit about the impacts he's seeing on his business and what steps we can take to control this into the future.
Thank you very much, Amanda. And thank you everybody for being here today. Again, I am working for Casella. Our division is the Casella Resource Solutions. So by name alone, you should understand we're working hard to ensure that we continue sustainable sludge and biosolids management into the future. As my bio said, we on a typical year manage anywhere from 700 to 800,000 tons of biosolids and other residuals, including mill ashes and limes and a variety of materials. Probably anywhere from 200 to 300,000 of that is in the state of Maine alone. So we do have a big impact on material recycling. So I do appreciate being in this position of being a later speaker, as I know what my time constraints are, plus all the salient points have been discussed. So I can shorten my talk and you'll benefit from that as well. Again, some of the things that have already been talked about, we talked about the PFAS task force and the report that was issued, and some of the recommendations from that I just wanted to highlight. And these were the kind of 8 overarching recommendations, and under each one of those there were subcategories. But I think 2 of the ones that are popping up here today are one, identifying reducing uses of PFAS, and Scott alluded to that in his discussion of the recent legislation from Maine legislators, and also managing waste responsibly. And that's the one that really is going to take up our topic today. And one of the guidance points we got from Marty at the start was, let's try to be positive. And unfortunately, we're going to have to sprinkle in a dose of reality here. But I think there is a lot of positive that we can take away from here. We're not giving up on responsibly and sustainably managing these materials, but it's going to require a big team effort. And when I say team, many of you in this audience are entrepreneurs and innovators, scientists and engineers. We've already partnered with many of you, and we'll continue those partnerships. But this is a societal issue, as Scott mentioned, and it's going to take a societal team to lead us into a successful resolution. So under the managing waste responsibility, I took 2 key recommendations out of that. Understanding that a very small portion of the task force had recommended prohibiting land spreading of residuals and biosolids, where most of the members had recognized that there was an agronomic benefit and an environmental benefit from recycling nutrients, improving soil health, and also from the greenhouse gas perspective, sequestering carbon. A second recommendation, and that's one that Scott had alluded to, that's not really happening quickly enough, is the investigation about the availability of treatment and disposal technologies. And I think at this point, we really need to look at destruction technologies, because otherwise we're just passing on the problem to either a later generation or a different area of the country. We really need to focus on how to actually remove those compounds that are already in our biosolids and in our environment in general. So just to recap what's going on in Maine, you hear a lot about there being 700 contaminated sites, and there's some confusion on what that really means. Does that mean that there's a bunch of licensed biosolid sites and every one of them is contaminated? No. Does that mean that of the 750 farms that are registered in Maine, that 700 of them are contaminated by PFAS? No, again. If you look at the DEP website in their database on PFAS contamination, you'll see a bunch of different sites. There are Air Force bases, and there are fire training centers and other things like that. And there are farms. And so if you dig down in the details, you'll find that a lot of those big sites are homes of individual sites, upwards of 60 to 75. So that number may be a little bit confusing to people when they hear it's not like every inch of the state of Maine is awash with PFAS. Likewise, when they say they're contaminated, that probably doesn't mean they're at the same level as we see some of these industrially impacted sites. That just means that they've probably got PFAS levels that exceed the soil ceiling limits that the DEP has prescribed. So just to break it down, in biosolids management, we have Class A and Class B biosolids, and that only refers to the treatment of pathogens. So essentially, in Class A treatment, the pathogenicity is taken down to essentially 0. And in Class B, there's treatment to take it to a level that's probably essentially background to what you would typically find in the soils where these materials are applied. So with that in mind, those Class B sites are generally restricted to the public, and also by law, they're prohibited from growing food for human consumption. Now, they can grow animal feed, and that may be a pathway, but direct consumption is not possible from these Class B sites. And then finally, the management of septage is also licensed by DEP, and these are disposal sites, not beneficial use. So anything grown there it doesn't find its way into commerce of any sort. Now spreading's been banned. Now what do we do? And this goes back to my earlier point. This is our challenge. And again, I think we have the people with the intellect and the enthusiasm and the drive to actually make this happen. Because right now, our only direct option for managing sludge now, I mean, you're not going to treat materials to biosolids level just to put them in a landfill. So we're probably talking about sludge disposal now. That's our only direct option. And as Rhonda described very well, there are limitations to that. So that means our only other real opportunity or option at this time is exportation. And that has its own inherent problems. It may violate commerce law. For example, if we're not able to manage our waste, is it fair for us to push our problems to other states? Other states have got restrictions. They adopt the management strategy and requirements of the state with the most restrictive rules. And then obviously there's going to be an increased transportation costs and greenhouse gas emissions. Technology for treatment, especially destruction, is desperately needed. Again, with capacity, again, it's already been discussed, but I just will comment that it's not a sludge management issue. It's a comprehensive waste management issue. The capacity constraints are region-wide, so this is not just a Maine problem. So, and as Rhonda pointed out, implementing new capacity is a staggering proposal, both in time and money. And the way we're pushing more sludge into landfills essentially means we're going to be consuming that capacity well before we have new capacity approved. Disposal options are intimately linked, especially regionally. And again, a lot of this has already been discussed. We have a moratoria in several states where you can't develop new landfills. Our sludge incinerator capacity is pretty much used up, and those units are fairly aged and routinely are down for repairs and maintenance. And of course, there's the whole emissions thing, because they may not be designed to trap PFAS that may be discharged in their emissions. Cost of management of these materials will increase. That's indisputable. Again, we've talked about the limited disposal capacity and how that will impact just by the economic law of supply and demand. The use of landfill capacity being used up more because of the bulking agents, and again, transportation costs. All those have to be passed on to the generators of the waste. And services will be less available. Again, to Rhonda's point about operational constraints, having enough material to bulk, having the operating hours to work in, and just the routine maintenance that has to go on with all these facilities is just going to exacerbate the capacity problem. So next steps, and here's the positive. We will continue to sustainably manage biosolids the best we can, either by developing new markets outside of Maine, New Hampshire, Vermont, where those restrictive laws keep us from, they have to follow Maine law, so we cannot market those areas. We'll look at new uses. For example, biochar in cement processes. That seems to be a new growing thing. Unfortunately, it's expensive. And again, you have to have adequate outlets for the material to make it viable. And again, because of it's a heating process, it may have some emissions concerns. And then finally, we really need to push for this implementation of new destruction technologies, and that approval must be accelerated. We'll find that Maine may not be the best location for that because of the concern about outlets, because basically with a ban on sludge utilization, doesn't matter how much PFAS is in it. So destroying it in sludge is not going to make the material land applicable, even though it should be. So one final comment, we've got to be more aggressive about keeping these things out of the wastewater system. And that's to Scott's point, that this is not a wastewater treatment facility problem. It's a societal problem. Whatever products we use are going to wind up in the wastewater system. And ironically, products that expose us to contaminants of emerging concern, not just PFAS, but other things, have until 2030 to find solutions or alternatives. While land application, which has a very limited breadth of impact, is essentially terminated immediately. That same level of urgency has got to be applied to all potential sources of exposure to these compounds. So the future, again, that depends on us, depends on you. I know we have a question roundtable, but I think we all have to approach this with a kind of wonderment and attention that this baby shows in this picture. This is going to take a very concentrated, collaborative effort to really come up with a system or a plan or a program that will help us to sustainably manage all our waste. But for this particular presentation, for biosolids and sludge. So I appreciate your time, and I will turn it back to the moderator.
Thank you, Jeff. You guys are keeping us right on time. I actually think we're still a little bit ahead of schedule. We didn't really have any direct questions that came in that are short and quick answers, so I think I'll hold most of those to the panel discussion. So we can move right ahead with our next speaker. So Neil Goldberg is the legislative analyst for the Maine Municipal Employees Health Trust, and with MMA, he is here to discuss how municipalities and industry are looking to deal with this problem into the future, and how these changes are going to maybe implemented and things handed down to the user.
Hello, everybody. My name is Neil Goldberg. I am a legislative advocate at Maine Municipal Association, and I'm here to briefly talk about kind of the current status of municipalities in this larger landscape of PFAS or PFOA. I just want to begin by saying thanks to E2Tech for having me here today. Thanks to Marty and his staff. This is a truly expert panel, and Amanda, our moderator, appropriately said it, which is we are a panel of experts and others. I like to think that I am the other here. I was very quick when I was invited that I can't really speak to the granular technical level as the other panelists, which is appropriate, allows me to actually take a step back and look at all of the different ways in which the changes to operations are impacting municipalities. And the municipal lens is a good one to look at this wider landscape because local governments truly are a jack of all trades. We are involved in so many different operations and services, both as a direct provider of services as well as a consumer of services. I think it should be noted that the majority of municipalities do not operate wastewater treatment plants. We are the consumer of those services and products, as well as we are the consumer of private industry provisions. For instance, our town halls and our community centers need their septic tanks to be pumped. We have to send our physical municipal sludge and septic somewhere. And so again, municipalities encompass a wide range of perspectives as well as needs. And so with that, I will, let me get to my next slide. So briefly up here, I have the macro look of what it is that municipalities do. It is far ranging. Clearly today, many of our panelists have honed in on the water, wastewater, and kind of sewer aspects, as well as waste management. But you'll see that municipalities do much more than that. And I put this up here, not because you all know this already, but to show that as the landscape and our understanding and discovery of PFAS continues, that it's going to have implications for almost every one of the operations and services we provide. We've already seen and felt some of those impacts, and we anticipate new implications, disruptions, threats, impacts in the future. Just to give some kind of brief examples, our public safety provision of fire services recently kind of hit a snag when we realized the high levels of PFAS in firefighting foams. The question in the chat came up earlier about testing for land, because land buyers want to know if the land is contaminated prior to purchasing. Well, clearly we are very conscious of what land use and land value means to the municipal bottom line. And so protecting our residents' health, protecting our businesses' viability, these are very important things to us. And so just trying to paint a broader picture of why it is municipalities are so concerned about all of these changes, disruptions, and threats to the way we go about our operations, as well as the way we subsist off of land value. And so just want to highlight a few other changes that have come to the way that we approach our operations because of our understanding of PFAS. Redevelopment of abandoned and blighted properties has been drastically changed. Our understanding of brownfield cleanups has drastically changed. PFAS has hit home truly for a lot of Mainers with the understanding of PFAS in locally harvested venison, fish. Our skiing industries were recently put under the microscope with the understanding of PFAS in ski wax. Our wastewater and treatment plant facilities, as has been touched on numerous times today, are under the microscope. And so municipalities are sort of reeling. We see this, again, coming down as a multifaceted threat. And we're sitting here thinking, well, what can we do? Because if you look at a town like Arundel, which has been in the news for its, I guess, high levels and prevalence of PFAS contamination, you think, can they handle this problem on their own? And the answer is clearly no. They are a town of less than 4,000 people. The remediation that they're going to need will cost millions and millions of dollars. And so MMA, municipalities as a whole, are looking at this thinking, we need some help. This is larger than one municipality. This is larger than one municipal budget. This requires expertise that exists far beyond the municipal level. And it requires technology solutions that do exist, as well as that don't exist, that we do need to develop. And so I sit here and I will kind of end this slide with my final message. I'm getting right to the thesis, which is we need solutions. We're going to need solutions to address in each and every one of these. And as the disruptions continue to occur, they're going to bump into each other. They're going to get magnified. And so seeing how it is that our policy decisions are impacting the other policy changes is a big part of what we need to be mindful of. And so I should also say that that explanation there really didn't cover what it is or the impacts to our partners. Municipalities rely on our public and private sector partners every single day. And so things that ultimately help them or hurt them are going to be passed down to municipalities and the businesses and the residents that reside within our boundaries. So if this issue is bigger than one municipality, then what is the state of Maine doing? And the answer is a lot. They are acutely aware of the presence of PFAS and the problems and threats that they present. And so I am really happy to say that there seems to be a lot of action and a flurry of activity at the state level. Recently, there have been completed task forces, studies, and recommendations. There was no shortage of legislative proposals in the 130th. I counted them at least 23 that touched on PFAS. The difficult problem with PFAS related legislation and policy changes is we don't really know what the best approach is. Sometimes we're grasping at policy levers, sometimes we're having knee-jerk reactions, but every time the same questions are being asked. What can we do? How can we provide relief to the people that need it or the businesses that need it? And where in the supply chain, where in the industry is the inflection point? Where can we actually make a change quickly, urgently, intelligently, sustainably? And so every piece of legislation is kind of answering those questions differently. Now, again, from the local level, we are desperately looking for solutions. And so whether it be from a technology partner or from the state, we are looking at these changes and thinking, if it helps, we're going to get on board. And so I'm happy to say that MMA's policy committee has been generally supportive of this entire portfolio of PFAS legislation. We again are on the grounds combating this stuff, but we do need help at just around every corner. And this, I will just take an aside and say, from a personal note, this PFAS related issues, policy changes have actually been a really uniting issue for our members. I had mentioned a moment ago how personally this is hitting home for some people, whether it be in their recreational activities, their health, their business's viability, the long-term environmental implications for next generations. And so for all these reasons, our policy committee has not hesitated once to say that this is something that's important. We need to get our hands around this and we need to start coming up with solutions, because we can't allow each and every one of the things we do to be changed forever. We're not able to adapt that quickly. Municipal governments are nimble, but we do not have endless resources. And so I would also give a nod and say the state, to their credit, has put a little bit of money where their mouth is, and they've also put an initial $60 million towards a PFAS fund. I use the word initial because everyone recognizes that this is going to require a lot of ongoing funding support. During some of those public meetings about those 23 pieces of legislation that I had mentioned, there were some great suggestions that came out about how it is how we can move forward as a state in a kind of unified approach. And one of them did catch everyone's eye or ear until we heard the price tag. And it was to have a sort of central state hub as a repository for all PFAS contaminated substances. It was a great idea and premise. It would centralize and secure all of these different substances. However, everyone started to balk at the idea of, say, a $200 million price tag. And so it just shows the amount of, I guess, support that we will all need. So here's I probably should have said, here's an example of what MMA would say would have been some really great policy design and implementation. And I chose this example, firefighting foams, and the soon-to-be prohibition of their use, because it also speaks a little bit to what we've talked about today, which is the need for source prevention. I saw in the comments, it's been mentioned that yes, the legislature is banning some commercial products that have intentionally added PFAS, like carpets and rugs, and the list will continue to grow over time. But I want to hone in on firefighting foams because it speaks to this idea of there are some things that we are doing today that we can't stop doing overnight. Clearly, there is a public safety element to using these firefighting foams. In some instances, they are the use of them are brushing up against federal preemptions. For instance, DOD needs to have use of these at our airports. And so ultimately, the implementation or the idea for this legislation to restrict the use of firefighting foams is going to change the way that we operate at the local level. And that is okay. What we liked about the way that this came together was that at first there was a limitation of use. The legislature went back for further research and study. They made some policy recommendations and then ultimately came forward with an even better and more robust plan that municipalities were able to see coming down the pipeline, the timeline, and prepare for. And happy to say that we are excited with the way this is going. Firefighting foams, as an example, also speaks to this idea that our wastewater treatment facility systems are really, again, the receivers of a lot of this contamination. They are certainly not adding PFAS into their supplies. And so this is coming to us down the pipeline. Now, again, we are here to talk about sludge spreading. And so before I end, I should briefly touch about why it is that this caught municipalities and why we supported the ban. Ultimately, this ban on land application of sludge is going to have municipal implications. Few municipalities are directly involved in this, but we are part of the larger landscape. And so we expect there to be cost implications. We expect there to be some environmental trade-offs that have to be made. But ultimately, from the MMA perspective and from the municipal perspective, we looked at this and said, this is the best thing for the health and safety of our residents right now, because there aren't really any other options that are available to us in an affordable manner. We look at this as a way to preserve and protect our land use. Again, if businesses are thinking that it is risky to operate in our boundaries, or if homeowners are thinking that their well water isn't safe, we need to get ahead of that. There are serious implications to our operations when land is questioned and land use value is questioned. And then finally, as a consumer and as a service provider, we realized that we will have to pass some of these impacts on. For instance, we know that residents that need their tanks pumped are going to be competing for private hauler contracts. The distances to the landfills have increased. There are fewer places to bring this product. And so we do expect there to be some cost increases, which we are happy to swallow because of what we think the long-term benefit will be. I will say I've spoken to some of our members and they are thinking we just can't send our sludge up to Juniper Ridge. And they are looking at other options, exportation. There are discussions with Massachusetts-based firms that are saying, yes, for the time being, we can take this product for you. And so it'll be interesting to see how municipalities react. And there already is a sort of rush for contracts. It's causing a lot of stress for our municipal officials. But I end kind of where I started a few moments ago, which is this is coming down the pipeline towards us in so many different ways. We are in search of solutions. We encourage our technology partners, our private and public entity partners to put forth ideas, and then ultimately we will be on board. And so apologies for rambling, but thank you for having me, and I will pass it back to Amanda.
Thank you, Neil. I think that truly did capture, the concerns that we have as a state around, disposal of these materials into the future. So we'll get ready to set up our panel discussion. I believe we're going to kind of be put on the screen here in a more Brady Bunch style so that you can see everybody. But as we're doing that, one of the things, just looking through the questions that we've received so far, that's kind of jumped out at me, while we jumped right into sludge and the impacts of this new law, we really didn't give any discussion to PFAS itself and why it is a concern. So some of the questions that we've received around, the treatment of PFAS, and there was a question about, the use of microbes for elimination and treatment of PFAS. Can somebody speak to why PFAS is such a challenging set of chemicals to treat, and why this is providing us such a challenge into the now?
I will give that a shot. Ultimately, the reason it's so hard to treat for is that was the design of the compounds. They're meant to be strong. They're meant to be persistent. And unfortunately, they do have toxicity. And early information we get is that they probably got an easy pass from FDA to get introduced into commerce. And so they really didn't look into what the potential outcome was after they did get introduced. So you have them in things like Gore-Tex, Scotchgard. It's in carpeting and fabric and furniture, and it's in our clothes. It's in food packaging. And so the early discussions with FDA basically said they would be inconsequential release from those materials. So, they'd stay where they were placed, but that wasn't necessarily the case, as we've seen. So that's why we're seeing PFAS. The reason it's difficult to treat, again, is because the way it's formulated, they're long chain carbon. So if you looked at a molecular size, you'd see anywhere from 4 to 10 or 12 carbons in a line, and each one of those would have attached to it a fluorine compound, fluorine atom. And those are some of the strongest bonds that are created in chemistry. So once they're bound, it's almost impossible to break them apart. So the discussion about microbial degradation, it happens, but it happens slowly. It was kind of ironic. They found a bog in New Jersey that had been contaminated with, I think it was PFAS. And they said there was some natural attenuation going on there because of a certain microbe that was associated with some sort of iron bacteria. But that's a small scale and not enough to really remediate the impact. So now you're looking at, thermal processes. And so that conventional incineration does not break those bonds. It just simply makes the PFAS airborne. So there's some ways to tweak incineration. I've heard studies related to adding a liming agent. So you have lower temperatures and the bonds will break. And then it just creates the atomic level particle. So it's fluorine and carbon, et cetera. Those, again, they have emissions concerns. So to get an incinerator that will actually destroy them, it's a few hundred degrees, and I can't remember if it's Celsius or Fahrenheit, above what a typical incinerator runs at, and even higher than a waste to energy facility, because the waste energy facilities depend on running at what they call autogenous temperatures, so that they continually keep themselves ignited and they don't have to add fuel. Once you add fuel to get the higher temperatures, you're no longer waste energy, so you lose your environmental credits for those operations. So it's a complicated, I'm not a chemist by any means, but the ultimate thing is they're tough buggers to break down. They do break down naturally. They have half-lives of a few years, which is orders of magnitude higher than a lot of chemicals, and that's the problem. So they are very persistent, and some of the older ones have known toxicities associated with them.
Amanda, if I could just add, because Jeff didn't really touch on the health impacts, but there's a lot of research going on right now, but these are endocrine disruptors. And I was just reading this morning a study that came out that's connecting it to non-alcoholic fatty liver disease. So cholesterol levels, there are some health impacts, but we need a lot more research in that area as well.
Yeah, and the liver, it's not surprising that the liver is an area where you see a lot of the impacts because the liver is a filter. So they
Yep.
do get filtered out by the liver. And so you see liver enlargement, but there's other things like a couple of cancers, testicular and kidney. There is thyroid issues. There's hypertension in pregnant women, increased cholesterol levels. And one of the more recent studies is showing there is some impact to the efficacy of vaccinations. So
Right.
it doesn't mean you're going to get sicker. It just means your vaccine may not last as long.
Okay, that was perfect. I actually was going to ask a question. I know none of us are toxicologists on this panel, so I think that was a good lead in. Thank you, Janine, for that. There was a question, actually, this is for you, Janine, or at least to start the discussion. There was a question around past concerns. You brought up past concerns around dioxins and PCBs, for example. Are there lessons that we've learned from those that can be those issues that we can apply to PFAS into the future?
Yeah, I would say do the science. That's definitely what got us through and to a point where everyone agreed on levels of different pollutants in the soil, in the biosolids that are applied to land. So we have to do the science, and EPA has initiated a risk assessment process for biosolids for PFOA and PFAS. They've engaged a science advisory board, which was supposed to have met, but will be meeting shortly. They basically fallen behind in this process, so we're looking at a couple of years before that risk assessment is completed, unfortunately.
Yeah, and one of the things we lose in having some of these things legislated rather than regulated. So instead of waiting for EPA to issue drinking water standards or health standards on biosolids, a lot of states have gone and established their own. If they're doing it in the form of a regulatory process, rulemaking, then it requires a cost benefit analysis. With legislation, there's no requirement for that. So we don't really know on the wide scale, on the global level, what the benefits are going to be, because what I mentioned earlier is, yeah, there is contamination. There's significant contamination in industrially impacted sites, but as a whole, both regionally and nationally, I don't think there's that level of contamination other than background levels. And that's the thing with PFAS. It's everywhere. I mean, if you're finding it in polar bears, where I don't believe they wear any Gore-Tex and they don't eat Big Macs, they have PFAS in their bloodstreams, and that's probably coming from their diet. They're eating fish and seals that migrate in the south and then come back north, or come back north in the summer. So that's probably where they're getting their PFAS, and it could be airborne as well.
Excellent. Thank you both. Does anybody else have anything to add to that before we move on to the next question? So we did have a question come in around PFAS manufacturers. Certainly that is a target, right? As we're looking forward to these product stewardship laws and the banning of the use of the materials. And the question really is around whether or not any of you feel that any of these remediation costs that we might be facing due to PFAS in our environment should be, passed on to the manufacturers.
Absolutely.
Yeah, I don't think you'd get any pushback on that other than from the manufacturers. And again, we're lucky in this state and actually lucky in this country because we had these funds available now. Because if we had to wait for compensation and reimbursement from the manufacturers, we'd probably be looking at 10 to 15 years before we could do anything. And I don't know where Maine is in the process of engaging in a lawsuit, but we're already behind other New Hampshire's filed lawsuits. I think Michigan has. There's a lot of entities that are already lining up to get their pound of flesh from the manufacturers. So where that lands us in the feeding order, I don't know. So yeah, we're quite fortunate in Maine that we've got local resources that we're already addressing some of the issues right now.
Excellent. And while we're on this topic, is there anybody that can speak a little bit more to the timeline of these bans? It seems like there's some confusion in the questions as to when each ban takes effect, whether that's a voluntary, some have done it voluntarily versus actually having the ban take effect.
Yeah, I think the food packaging one, which was approved last year, might have been superseded by this year's legislation on any intentionally added PFAS compounds. So the reporting begins in 2023, as Scott mentioned, and the actual removal from commerce would be 2030. And I think that's across the board of any commercial product. So there may be some loopholes or workarounds. Obviously, not all countries are on board with elimination of these because they're not listed under any of the hazardous waste programs, RCRA, CERCLA, et cetera. They may not be discoverable. For instance, if you have a listed compound, it has to show up on an SDS, safety data sheet, which lists all the hazardous compounds. That's not required because it's not listed. So a lot of companies will say it's proprietary and they're not going to release that information. And they'll be very cagey when you call them and ask them, well, can you just tell us off the record if there's PFAS? So there's going to probably be some other regulatory changes needed before we can fully vet it at the source. But at least it's a good start, and I just wish it would be starting sooner.
Thank you. Rhonda, could you speak a little bit more to, you brought up the use of landfills for disposal as currently that is the one option we have as these other things are studied and developed. Could you speak to why landfill settings really are the best place at this time for disposal of PFAS contaminating materials? And then maybe a little bit to, how that actually does play back to treatment facilities through, the production of leachate in these facilities that then also need treatment.
So landfills that have capacity are good locations because they have the infrastructure in place to handle the liquid waste that's going to be generated and basically just to manage the waste. Landfills that are constructed in the state of Maine have to have a pretty well-engineered liner system, and that's to prevent materials from escaping the landfill and getting into the surrounding area. So you basically have an environment there where it's already contained. So that's what makes them a good place for, if they have capacity for containing that material. And what was the second part of the question?
Can you kind of speak to, I guess, the loop that exists between our landfills and our treatment facilities when it comes to like leachate movement and things like that?
Right. They are able to help each other out. I mean, the landfill, again, that's a contained space where you can put the waste and it's contained. The treatment plant has the ability to take material and treat it to remove those, inorganics and organics before it's discharged. But in the process, they generate sludge. So that connection exists in that a landfill can send their material to a treatment plant, have the liquid waste from the landfill, treated before it's discharged, and the byproduct of waste treatment, that sludge, can then go back to the landfill in a more concentrated form where it can retain, be contained.
Thank you.
Amanda, if I could just add,
sure,
because EPA has issued some destruction disposal guidance, which they're going to be looking at on a regular basis. But the landfilling was identified as at least being a sink, a disposal facility where we could contain it and manage it. And the other things they discussed were thermal processes that have potential, and also underground injection, which we don't have around here. I guess that must be a thing from out west. But they're going to be they have an active research team that's looking at these technologies now for destruction.
Good. So it looks like we may have some support at the federal level as we move forward with this as well. That is excellent. Can somebody speak to the levels of Maine's targeted compounds? What are our screening standards compared to what other soil amendments might be, or other contaminants that we might be more used to seeing? Certainly they are quite low level for PFAS. I don't know if anybody wants to kind of talk about that a little bit.
It's kind of a moot point now with the ban, but prior to the ban, we had PFOS was 5.2 parts per billion, PFOA was 2.5, and PFBS was 1900 parts per billion. So that always confuses people because the drinking water standards are in the parts per trillion. The reason they're that whole order of magnitude higher is because in biosolids and other organic materials, those tend to be fairly well bound to the organic portion of the waste. So they're pretty immobile, which begs the question, well, why do we have these groundwater contaminations near these industrial impacted sites? And the only thing I can speculate is those materials that were used 30 and 40 years ago were so highly contaminated that there wasn't enough organic matter to keep them all from migrating. But what we do see is that in long-term use biosolid sites, the research shows that there is some migration from those if they're at the background levels, but it usually doesn't extend much more than 3 to 6 feet below the surface. So there's a lot of different things that we still don't know enough about. That's another area of research that we're still looking for additional information on, is the long-term impacts, what are the levels. A lot of the epidemiology, in fact, we look at is really targeting industrially impacted sites. So West Virginia, where they had a manufacturing plant, over in Germany, where they just basically had disposal of industrial sludge in basically near communities. So there's still a lot of balls in the research area that we don't have enough information. But the other part of it was other materials. The bottom line is, if you look for it, you're going to find it. So it just really doesn't matter what materials you're talking about. I mean, we have sludges in our suite of materials we manage that have basically non-detects, and that's at the low levels of, I think that the current lab levels are now below 1 part per billion. So that's fairly insignificant from that perspective. And we'll have other things that maybe would seemingly be innocuous, like food waste, something made from food waste compound. Well, guess what? There may have been some food wrappers associated with that food waste compost. So there may be some PFAS there. So again, if you look for it, you're probably going to find it. And it can be at both under and above the screening levels of the Maine. Because again, those screening levels will still apply to other products, I would assume, that are waste generated or waste based.
Sure. Let's see, we have a couple questions that just came in. So Rhonda touched on the fact that landfill leachate is also another constituent that goes to wastewater treatment facilities. Are there other specific waste streams that feed into the water treatment facilities? Maybe touch on that.
You mean that are PFAS containing materials?
Well, I would say just in general, and then to follow up on that, which ones have we found really are or may be higher in PFAS levels, just so that people have an understanding of what materials do come into our treatment facilities.
I'll take a stab, I guess. I mean, certainly paper manufacturing type of processes are where we look right away, but we're finding some surprising things. Vermont, I just went through some research yesterday. Vermont's done a study, and really just looking at residential neighborhoods. There's not a lot of businesses in Vermont, and they're still finding it in significant concentrations coming from residential settings, not even industrial settings. And other interest, so other industries like dry cleaners we're looking at. And in Vermont, again, interestingly, they found that schools were generating a lot of PFAS due to the wax and the cleaning operations there in schools. So yeah, when we look, we are definitely finding it, but there's some industries that we know use it that are targets for our pre-treatment programs, and those folks trying to reduce what's coming in to the treatment facility to start.
And I'd just like to add that, I mentioned we tested domestic septage, and the domestic septage, that's obviously material that's concentrated over years, but it's coming out of residential homes. I'm aware of testing that's been done at treatment plants here in Maine that really don't have industrial bases. They've got some commercial, they've got some food processing, and they have a lot of residents, but they're finding levels of PFAS in the influent. And I think that's one of the challenges here is we are trying to figure out where this is. We can test for a handful of compounds right now. I'm told there's 9,000 plus PFAS compounds. Several hundred of those are probably in use. And then one of the challenges we also face is that as we find alternatives, EPA just published concerns over Gen X, which was a replacement for some of the compounds that have been removed. And that appears to be more toxic than what it replaced. And that's one of the challenges here is we're chasing and not sure exactly what we're chasing and not clear what we're finding.
So while I have you, Scott, before you mute yourself, are there any treatment technologies that you're studying currently or that you've heard about that show promising potential?
Well, I think the big challenge is scalability. I talked about pyrolysis. There's a facility operating in Silicon Valley that's successfully doing pyrolysis. There's some technologies implemented in Europe. But trying to get those technologies and demonstrate scalability, cost, and also PFAS destruction is a challenge. I mentioned we're involved with the Water Research Foundation where we sponsored a project and it's specifically looking at performance, cost, and PFAS destruction of pyrolysis, which is one of the leading technologies for treating solids. That facility was supposed to start up last June. It still hasn't started up. There's a material handling issue. So we're not going to actually be able to test biosolids going in and being fully treated. So we're finding dried product that we can literally force into this system so that we can at least do some work on PFAS destruction. One of the big questions out there, even with sludge dryers, there's been a concern expressed by DEP about PFAS emissions. And there's currently no accepted testing method. There's an OTM method that costs tens of thousands of dollars. There is a WRF study out there on incineration right now that's trying to do a mass balance of PFAS in sewage sludge incinerators and look at thermal destruction of PFAS. That's ongoing. Reports are in 9 to 10 months. We should have some information out of that, hopefully having a mass balance. But that's the challenge here is we're chasing something that's not quite ready for prime time. My hope is that these market conditions will accelerate that and capitalism will kick in and ultimately we'll find some solutions with partners like the people that are on this phone call or this Zoom meeting.
And tied in, there actually is some research going on in Maine. The Anson-Madison Sanitary District is looking at a pilot study with what's called foam fractionation. But that unfortunately is just a removal process, not a destruction process. So it concentrates it. And there are destruction technologies. That's what the water districts that use the granular activated carbon are doing, sending the material out for reconstitution. So I would assume those same facilities could take the concentrated PFAS waste and treat that. But that's an out-of-state thing. And right now it's undergone a few months, from what I hear, with some success. And again, whether it's scalable or not, we don't know. I would hope so. But again, that's just a removal technology.
But Jeff, you make a good point because we do know how to get it out of drinking water. The technologies are there. I mean, it's not cheap, but we can do it. And that's what I've been trying to advocate for is let's start at that point in the water cycle, because that will reduce the levels in wastewater and it will reduce the levels in biosolids.
Right, because what you're doing is you're going to hit it on the influence side, so it doesn't have a chance. Well, again, if it's bound to a solid, it's going to stay with a solid more likely than not.
Right.
But it does decrease the amount that winds up in the liquid portion of the biosolid. So I think there would be some incremental value. But that being said, the real crux of our issue is we need something that addresses the overall concentration in biosolids, and that may be a few more years out.
Thank you. There was a question that came in around PFAS testing in other soil amendments. Do we know if any of that has been done in non-sludge soil amendments, if any of that has been done?
Jeff's done a lot of it.
Yeah. We did some, just, grabbed a bunch of stuff off the shelf. We didn't actually sample it. We just took the product and then contracted with a lab to do the sampling, and they sent it to one of the few PFAS labs in the country. But prior to that, there's already a lot of information out there, studies in, I believe, either Australia or New Zealand, maybe the UK. There are some in-country research studies that, again, things that are basically promoted as organic. Again, we can't escape it. It's there in those products too. Granted, it's on a more a lower level. It's either right at background or maybe a little bit less. There are some materials that have actually tested above the screening levels. And again, it all depends on source of material and the processing. So yeah, nothing is really exempt from having PFAS in it unless it's created in a bubble. And that's the unfortunate thing with the ubiquitousness of PFAS, is it spreads, and it's going to be in about everything. But again, it's similar to our lower PFAS concentration sludges. Those materials should be able to be safely used, because at those low concentrations, those materials are organic. And when I say organic, I mean in the small o, containing carbon and hydrogen. They're going to bind those low levels pretty well. So there's going to be minimal uptake in the crops, minimal movement out of the soil. So those are not concerning. It's the ones that are industrially impacted, where they, for whatever reason, use copious amounts of PFAS in their process. And it must have been cheap, because it made it right down the drain to the treatment plants. Again, that's historical. That's 30, 40, 50 years ago. And I'm sure with some of the newer compounds, they're still not being sought or seen by a treatment plant, because no one knew. They're supposed to stay in the products they are applied to. So with industrial pretreatment, a lot of that has been taken care of, because we do a pretty comprehensive questioning of the facility. What are you going to discharge? What are the chemicals you use? So if anything popped up on the radar, such as a volatile organic or semi-volatile organic or metal or whatever, those are going to be flagged. And before that material could ever be discharged, that would have to be treated on site.
Excellent, thanks. We did have a question regarding some of the, the farm properties, obviously, that we've seen that have contamination. Are any of you aware of any programs the state may be looking to implement where they could potentially work with these farmers and use them as trial remediation sites, for example, to start testing some of these technologies and maybe offset some of the losses that the farmers are seeing?
I know that there are programs being developed for remediation, maybe not so much on a trial basis, but I think that's a great idea. Again, we really want to make these impacted farms whole again. And if that makes them part of a trial process where they gain some benefit, yeah, I say that may accelerate our ability to understand how to remediate. But I'm not aware of anything actively being done. And some of it may be, some of these sites may be involved in litigation. So any change of operation probably would not be allowed until those lawsuits were settled. And I don't know that for a fact, but I know that at least in the case of the Arundel farm, there was an initial lawsuit filed, was rescinded for something, and I think it's been reissued. But I haven't followed that very closely. But certainly, if there's litigation involved, there's not going to be any more testing, or at least outside testing or outside activity for remediation until that's resolved.
Okay. I do have one or two more questions before we kind of start doing our wrap up here. There have been a couple of questions here regarding testing of landowner wells, homeowner wells. Some of the questions are who should test? If you lived closer to a farm, is that more important? And then how would they go about doing the testing? And maybe at this point also talk about how testing for PFAS really does have specific requirements where other things don't. So does anybody want to tackle that?
Yeah, I mean, you're right that there's you can easily contaminate a sample because PFAS is everywhere. I'm not aware of any programs in Maine, but there are companies out there, laboratories that are certified to do this. And I'm going to guess, Jeff, some of the local, like a Northern Tilt or some of these companies that work with farmers all the time have the ability to manage that process for people and do the testing.
Yeah, and I will say, Amanda, you've probably got one of the premier experts in your operation with Liz. And yeah, there's some critical things that have to be considered while sampling. And it's not just, Joe homeowners should be doing it because they could potentially be adding unknowingly to their sample and may get a false read. That being said, there's plenty of the environmental labs are doing that work. They know the proper labs to go to. They know the proper sampling procedures. I mean, it's comprehensive, but it's not insurmountable. I mean, anybody could be trained to do it. But if you really want to get a defensible, undeniable result, it's probably better to bring a professional in. And that can easily be done by contacting any of the local environmental labs. You can go to I think you actually can go to the Maine drinking water program, and they'll have a list of those labs. And there may even be some guidance for them. I know they're dealing with public water systems, but they may have some advice for private homeowner wells.
Excellent, thank you. And then I got a couple questions for Neil as we wrap this up. Neil, can you talk about if you've heard whether there are any concerns of some of the individuals in these municipalities and how those concerns may be lining up with the overall concerns of the municipality? So are we kind of all in sync on what we're thinking about, or is there some variance there?
Sure. MMA generally isn't fielding many individual complaints or comments. However, I do like to think that our members, municipal officials, are quite reflective of the larger opinion and sentiment, which is this stuff is striking close to home, as close to home as possible, our drinking wells, our health. And so there is certainly, I think at the very, very local level, on the individual level, a lot of fear of what this could be. For the majority of individuals in Maine, they are not at risk of contamination in their drinking water. And so what we're hearing is we can't let this get worse. We need to know where it exists and we need to mitigate the problem there. But I have a lot of members saying, this isn't happening in our backyards. And they've had residents reach out to DEP for testing, and DEP has appropriately said, there's no reason to test. There isn't really any identified spreading nearby, or there's no reason to think that your well is at risk. So, don't worry. I can give an example. One business did reach out to me. They are a summer camp that supplies drinking water through their private well to 200 children that come to our state. And they said, hey, we're very close to an identified potential spreading site. Should we have our water tested? And I told them, go speak to DEP. They're the ones that are really going to be able to help you identify if you are an urgent threat or a priority. And essentially what DEP said was, you're upstream. So if there was spreading, which they weren't able to confirm, that these chemicals are not moving uphill. And so they told the business that you're safe. Clearly that business could have tested on their own, footed that cost. But again, I think it's that encapsulates the larger concern, which is we are hearing from our neighbors that they're having issues, and we're assuming that it applies to ourselves. And so certainly correcting the misconceptions, but as well as getting ahead of the misconceptions are a big part of what municipal officials are trying to do right now. So, thank you.
Thank you. Thank you. I think that's very helpful. So I think we're going to wrap up our question and answer portion for today. We do have a few questions that I think do certainly deserve to be answered. So I think we will follow up with some written responses to these, or at least some links maybe to where there is some additional available information for people to continue this discussion. But I would like to go down through our speakers for today and just give them an opportunity to really close out the session with some of their thoughts and hopes maybe for the future. So Janine, if you'd like to take it away.
Thank you, Amanda. Yeah, so just in summary, managing these materials isn't just Maine's problem. It's a national and regional problem. And I think we need a regional solution. And I happen to be involved in a terrific regional clean water group you may have heard of, NUEPIC, the New England Interstate Water Pollution Control Commission. Susan Sullivan is the executive director, and we've had many conversations about this problem and potential regional solutions. She has a lot of great ideas, and NUEPIC has the ability to pull together all the right people. What we've been talking about is establishing a PFAS or biosolids biotechnology hub, basically, in Maine. We were talking about locating that in the state of Maine, and the goal would be to bring these new technologies forward quickly and vet them, test them, and provide that information to local utilities so they can start making some decisions on capital planning. So yeah, they would hopefully develop some of these PFAS technologies and vet them, maybe work with the farmers on the cleanup aspect. Somebody mentioned that, great idea. So, and because if we don't figure a way to keep these emerging pollutants out, and PFAS is the current one, microplastics is a future one, we need to find ways to keep those materials out of the solids so that we can continue to beneficially reuse them, which is the most sustainable option in my opinion. It's the best and highest use of those materials. So I want to stress that these are just preliminary discussions, but they're very exciting. I'm very excited to help NUEPIC start that discussion, and possibly with a lot of federal funding coming down for clean water infrastructure, there may be opportunities to construct such a facility in Maine. So I just wanted to leave you all with that sort of positive and forward thinking aspect of the problem, and maybe having a solution there in Maine.
Thank you, Janine. That is certainly an encouraging that we are thinking forward. Rhonda, do you have anything to add to that?
I'll just echo, I agree it's a regional solution. And I think going forward, what we're looking at doing is really having all the groups involved kind of come to the table and really share their info. So that means really getting a firm handle on what amount of sludge and septic we're looking at for disposal in landfills or otherwise, and then really trying to understand from the wastewater treatment plants as this goes forward, what are they seeing for impacts, and really just using that information to help us figure out where we can distribute this around the state, what landfills around the state have capacity, and as a state working to figure out how we're going to overall manage this waste.
Thank you. Scott, do you have any thoughts for us?
Yeah, I was asked to think about things that are positive and forward thinking. So I'm going to start today by having tacos for lunch. DEP has been, certainly leading with standards, one of the most proactive responses in the country. DEP's current approach with residuals really focuses on sampling response at the specific sites. I think it would be helpful if DEP could take a leadership role in terms of not just biosolids, but the solid waste issue. We see 1639 and the impact that might have on C and D. As we're implementing these policies, as we're looking for solutions, a collaborative effort certainly makes sense. Utilities and municipalities can't do this on our own. And one of the things I've learned in the last year or two is we really need our policymakers engaged as well. I can't be working on a solution if it's not something that policymakers can get behind. And the final plea I'll put in as a municipal employee, as someone responsible for operating treatment plants, is funding and assistance. This shouldn't be borne solely by our ratepayers. Again, this is a societal issue. Thanks for hosting this conversation, and I'm really looking forward to finding solutions and moving forward.
Thank you, Scott. Jeff, do you have any hopes and dreams for the future?
Absolutely. I am totally encouraged. I look at the pace of technology development and implementation, and it's exponential compared to when I was a kid. And despite what you may have heard, that was not highlighted by the invention of the wheel. I see the potential is out there, but again, it has to be done as a collaborative, not as individuals going out and looking at their little pieces. I mean, sometimes you need that for good research. It's a bigger problem, but I think at this point, we kind of have a good target, and it's now time to bring us all together, especially the innovators and the entrepreneurs, and kind of help them in their efforts to help us. So again, it's a positive on that note. You know, as Janine said, there's other things coming, but if you look at PFAS and how it's treated / destroyed, it seems like the hardest nut to crack. So anything after that will be piece of cake. And I know we have the will and the ability to do that, because if you look to 2020, we didn't have a vaccine for COVID, but there was a will, there was smart people, and there was support, and that was rolled out well in advance of what would normally be done. So there is hope for us in the treatment realm as well.
Thank you, Jeff. And we'll wrap up with Neil. Any closing thoughts for us?
Absolutely, and a really positive one. You know, I always think of Maine as a state on the frontier of so many great solutions and policy ideas, whether it be EPR or offshore wind. I mean, these are topics that I'm working with. And PFAS actually presents another opportunity here for Maine to be both a thought leader and a technology leader. If we do come up with workable solutions, sustainable long-term solutions, they're going to be mirrored in other states that are kind of just beginning to grapple and wrap their heads around this. And so for our innovators and entrepreneurs, there's an opportunity here. And there's an opportunity for Maine to put itself on the map, kind of what Janine was saying, maybe as a tech hub. But so there is some positive light at the end of the tunnel, that what we figure out might also be applied around the country. And I'm hopeful of that. Thank you.
Thank you. I agree. I want to take one last minute just to thank everybody for your continued interest and hard work on this subject. I truly do believe that it's meetings like this where we can get these minds together, where we're going to have these beginnings of discussions. We're going to discover these opportunities, and we're going to help solve these problems. So thank you all for attending and for offering to share your knowledge with all of us.
Thank you, Amanda. What a great panel. Riley, thanks for making this work in the background. E2 Tech forums are developed by a program committee, and a subcommittee for this one included lots of great people, including Jeremy Fink from Hydro International, Juliette Brown from Veril, Peter Moline from St. Germain, and Tom Eschner from TRC, who is our board chair. And then also Megan DeRosa from Burns and Mac, who I forgot to thank and mention as a sustaining champion of E2 Tech at the beginning of the forum. Oh my gosh, what have I done? So there's their website. Please work with Burns and Mac when you get the chance. And hey, this was a Zoom. Are we sick of Zoom? We're sick of Zoom. This is in person on May 18th, Wednesday, May 18th at Maine Beer Company. Would love to see you there. I think this one will sell out. 200-ish, 250 people is what we can accommodate. Thank you to these sponsors for making it happen. Thank you again, panel. The recording is coming out. We're going to do it as quick as we can. I know a lot of people want to see it. You're going to get the slides and also the Q&A. And that's just a great way to capture this discussion. And to Janine's point, we're hoping to continue convening around this and be part of developing solutions. So thank you. I look forward to seeing you on Wednesday, May 18th. If not before, and we'll wrap the morning there. Stay positive, stay motivated. See you Wednesday, May 18th.
Thanks, Marty.
Cheers. Have a wonderful day.
Thanks, Marty.